Assalamualaikum and selamat sejahtera to Madam Zafika. So in this video, we will be representing on the earthwork. So let's start. What is earthwork? Earthwork is a process whereby the surface of the earth is excavated and transported to and compacted at another location. Earthwork processes will always be carried out at an early stage in a construction project. The completion of the earthworks within the scheduled time is often the key to the completion on time of the whole project. Okay, so now moving on to the type of earthwork. So there are three types of earthwork, which are excavation, slope stabilization, and backfilling. So as for excavation, this type of earthwork is referred to when it comes to preparing the ground for the construction of a buried structure. There are many types of excavation such as bulk excavation, rock excavation, and trench excavation. Bulk excavation involves the removal of large quantities of ground materials, including soil, rock, sand, and other materials. Rock excavation is a specific type of excavation that involves the removal of solid rock or hard rock formations from the ground during construction or mining activities. Next, slope stabilization. Slope stabilization refers to any implemented technique that aims to stabilize an unstable or inadequately stable slope. The purpose of slope stabilization technique is to increase the factor of safety of a slope to a level that is considered adequate. Lastly, backfilling. Backfilling is the process of filling in the excavated area around a foundation or structure. The backfill material can be anything from soil to gravel and is usually compacted to provide support and stability.
Next, I will be explaining on the typical construction process. The three most common types of construction used in earthwork are bulk excavation, rock excavation, and trench excavation. Firstly, bulk excavation is carried out to ensure that the site is in the most suitable height or level before a construction project can take place. This is done by executing the process of set out, clearing vegetation, removing topsoil, remove and replace any unsuitable material, cuttings and embankment, spoil, and finally, the quality check. Secondly, rock excavation is the term used to describe the removal of any dense, compacted, or cemented materials which require the use of blasting or ripping and digging tools that are larger than those used for common excavation. It is powered by the excavator's auxiliary hydraulic system, which has a foot-operated valve installed for this use. For works too big for jackhammering or in locations where blasting is not feasible due to safety or environmental concerns, demolition workers use the pneumatic breaker. The explosives used for blasting are typically meant for commercial usage and designed to explode with a controlled release of energy. Finally, trench excavations are narrow excavations that are typically used for strip foundations and buried services like cables and pipelines. To prevent collapse, the trench might be constructed vertical, slanted, or stepped. A trench excavation for rainwater drainage should accomplish 1 in 80 gradients, which equals to 1.25 cm in 1 meter. For this reason, an excavator must apply as much trial and error work to meet the requirement of the finishing level. One of the most used standard guidelines is in accordance to the Department of Occupational Safety and Health. Under the section of construction safety for excavation work, it is implied that a safe system of work is needed when hazards cannot be physically eliminated and certain elements of risk remain. This includes considering work preparation and authorization required at the start of any job, ensuring clear planning of job sequences, specifying safe work methods and necessary safety measures, including a safe means of escape and access where relevant, and considering tasks such as dismantling and disposal of building materials at the end of each job.
For the case study, our group had chosen the Ilham Tower Kuala Lumpur. Ilham Tower is a 58-story with 274-meter tall skyscraper located in Kuala Lumpur, Malaysia. It comprises of 22 levels of service apartments and 33 floors of office space with a 4-level basement and a 5-story podium built together to produce a total gross floor area GFA of roughly 93,000 meters square. The period of construction is 5 years. The pictures shown are the location of the project. The table shows the parties involved in the construction of the project. The client for the project is the IB Tower Sajan Berhad. The design architects is Foster's and Partners, an international architect from United Kingdom. The associated architect is SA Architect Sajan Berhad. For the civil and structural engineer, it is TY Lane International Sajan Berhad. For the M&E engineer is Jurutora Perunding Valjan Sajan Berhad. The quantity surveyor for the project is the Arcadis Malaysia Sajan Berhad. And lastly, the main contractor is the Daewoo Engineering and Construction Sajan Berhad. There are two types of soil. Number one, soft sediment soil. Ilham Tower is built on soft sediment soil, which is highly deformable and weak. It consists of loose particles such as silt, clay, sand, and also organic matters, making it prone to erosion and also movement. To increase the strength and stability of the soil, compaction, soil stabilization, and also dewatering methods are employed. The next one, fill soil. Fill soil is transported and deposited soil used for raising ground levels or filling excavated areas. Residual soil, on the other hand, formed from weathering of rocks in its original location. Factors like climate, leaching, and parent rock type influence the characteristic of residual soil.
For the next part is scope and magnitude. Firstly is the scope of earthwork excavation. It involves tasks like site preparation, topsoil removal, bulk excavation, grading and shaping, and lastly is cut and filling operation. These tasks including clearing vegetation, removing obstacle, reshaping ground surface, and lastly achieving desired site grades. The scope is determined by the project needs, design, and site-specific factors. For the second one is magnitude of earthwork excavation. It refers to the volume of material that needs to be excavated during construction. Factors such as project size, building dimensions, site topography, and soil conditions determine the magnitude. For the accurate assessment of the magnitude is important for project planning, cost estimation, and also resource allocation. The scope and magnitude are very based on project-specific factors, and consulting professionals is essential to determine the precise requirement. For the equipment and tool use, firstly is crawler excavation, used to dig and remove soil, rocks, and other excavation material on site. The bucket is downward and dragged toward the machine upwards to hold the loads. Second one, backhoe loaders. It is a combination of both loader and excavator. It is consists of load bucket on the front and digging bucket on the backhoe arm. Next one, for the equipment, surveying and measurement tools such as laser level, total station, GPS equipment are needed in order to measure and to monitor the depth, slope, and alignment of the excavation. Next one is bulldozer with a powerful machine and a wide blade mount on the front. It is used to push the soil, rock, and debris away from the excavation area. The next one is excavation safety. It is important also during excavation as a precaution, for example such as for hard hats, high visibility vests, and steel boots, also hearing protection. And lastly is dump truck, used in excavation for numerous pieces of equipment that move massive amount of loose soil material, including soil, sand, ores, and demolish trash away from the deep pit. For the next part is technique used. Firstly, the type of excavation. In this case study, basement construction is done using top-down excavation technique. The construction starts from the top and move downwards with the superstructure being built after each slab is completed. Slab acts as supports against earth pressure. The process involves building retaining walls, constructing piles under the columns of the superstructure, placing column on the piles, and installing formwork for each slab as excavation progress. For the grading technique, in top-down excavation, grading techniques are used to shape and level the ground surface during the downward excavation process. Grading is really important for proper drainage, desired slope, and stable surface for construction. The technique used including cut and fill grading, slope grading, surface leveling, surface compaction, and lastly surface finishing. This technique helps to balance earthwork volume, establish slopes, level the surface, compact the filling material, and provide the desired final surface. It also requires careful planning, execution, and monitoring to ensure safety and stability throughout the process. For the backfilling technique, in top-down excavation, several backfilling methods can be employed depending on the specific project requirement. Granular backfilling is applied when well-compacted granular materials such as sand, gravel, or crushed stone laid used to fill the excavated area. This material provides good drainage stability and can be easily be compacted. Granular backfill is often used in areas where water infiltration or soil settlement is a concern. Now, I will present to you about the safety procedures that was used on our case study. Firstly, risk assessment and planning. Numerous considerations such as soil stability, groundwater levels, nearby structures, and underground utilities should be taken into account during this evaluation. Secondly, competent personnel. The skilled workers have to be capable of using excavation equipment, comprehending soil mechanics, and implementing appropriate safety measures. Thirdly, excavation support systems. Shoring, bracing, and underpinning procedures can be used to avoid soil collapse and protect structural integrity of nearby buildings. Then, safety equipment and personal protective equipment (PPE), hard hats, safety harnesses, high visibility gear, gloves, safety boots, and respiratory protection when required are all examples of PPE and safety gear. Lastly, emergency preparedness. The steps to be taken in the case of an accident, injury, or other emergency situation should be outlined in a well-defined emergency response plan prepared by the project's safety officer. Next, it is the environmental regulations that was applied for our case study. Firstly, environmental impact assessment (EIA). This evaluation determines if the project will have any potential negative effects on the environment and verifies that environmental laws are being followed. Secondly, sediment and erosion control. It is possible to successfully manage sediment and stop its migration into water bodies by putting it to use best management practices. Meanwhile, to avoid excessive erosion, floods, and pollution of surrounding water bodies, proper stormwater management measures should be used. Thirdly, water management. Dewatering operations must be managed whenever there is a presence of groundwater excess during excavation works to reduce any negative effects on the environment, including monitoring and regulating flow rates and discharge quality. Furthermore, waste management, segregation, recycling, and so on are just a few of the proper waste management procedures that need to be followed to avoid potentially dangerous elements as well as dirt and debris from excavation wastage. Lastly, restoration and rehabilitation. Deep pit excavation should be followed by site restoration and rehabilitation work to return the area to its original condition or one that is better. Revegetation, erosion management, and the restoration of natural ecosystems may be necessary for this. Last but not least, there are a number of problems and solutions that we had identified during the execution of deep pit excavation works on our case study. The first problem is cramped and restricted space. The major restriction is to transfer an excavated material from the top-down excavation to the location of disposal areas that are situated off-site, as there is not enough room on the project site to designate a disposal spot for the removal of excavated material works. Secondly, condition of the soil and the surrounding buildings. If the excavation technique chosen is not suitable for the ground condition at the site, it may induce ground settling owing to the subsoil condition, which might have an impact on the nearby existing structures. Now, the solutions for the problems are firstly, adjustment of schedule for transportation plans. The project manager should designate extra loading trucks and stand by every hour for the evacuation of excavated material. It is advisable that the removal of excavation material not to be scheduled during busy times. Secondly, enhance the method of excavation to be used. Given that there are already structures around the project site, top-down construction is the best option. To support the lateral soil pressure, additional temporary ground anchors shall also be erected.